we manage a platform called the core platform. It's a platform as a service that's built on top of Kubernetes. And a lot of our challenges come from the level of multi-tenancy that we have in our environments, and the goal to give as much autonomy to our tenants as possible. So we're going to look at two use cases, one that we briefly touched on, Tim briefly touched on, and a slight variation. So the core platform itself hosts services from multiple different departments, and these are really large autonomous departments, almost like their own organizations, hundreds of engineers inside it, and well over 1,000 engineers using the same clusters. They have a lot of autonomy in deciding the tech stacks that they use, and their software delivery lifecycle is really independent as well often. And so what we do as a central core engineering team is we provided a common abstraction layer to really deliver on the hybrid cloud strategy that they have at Sky and NBCU. And that allows us to concentrate the effort on a small set of infrastructure teams to do all the cloud provider integration. And the combination of these abstractions that we've built, which are mainly controllers and operators, and the underlying infrastructure is what we call the core platform. And so really our mission is to give these independent teams that have their own services full service ownership all the way to production. And so we're going to look at how network policies play in that. So the first thing is we needed to implement a central overriding deny list. And so if we just start off with our clusters and the tenants, we know that network policies can allow us to create a perimeter around the namespace. And like we were just saying, we want the tenants to really be the only ones managing that network policy if possible. What we do as a platforming team is we either using a gatekeeper or custom admission controllers will try to ensure the right level of governance is in place as part of them doing their day-to-day changes to that network policy. So after that, a requirement came in from a central security function, and it's slightly different for the Sky case and the NBCU case, but ultimately they had a default deny list that they wanted implemented at the perimeter, and that needed to be as soon as possible from the change. And this is really to prevent egressing out from our clusters to known malicious endpoints that they've identified through that threat intelligence that they run. And that's really where cluster-wide network policies made a massive difference to us and simplified the scope of that work, because it can create easily a perimeter boundary for us. And really what's left for us to do as a platforming team is just build a service that integrates their deny, that syncs up their deny list with that network policy. And I think it looks pretty simple, but it actually, from a delivery perspective, made a massive difference, because we're not really dealing with a greenfield environment. We've been using Kubernetes for about 4.5 years now. And so a lot of these environments originally were very permissive. And so as part of expansion, there's been a desire to move to a default deny strategy for all of our networks, including within the cluster. And so the difficulty really there from a pragmatic perspective is, how do you take 90 teams that are managing 300 applications and that have been in permissive environments for the last 7 years, and do a big bang perimeter default deny, which was the original suggestion. And so really by being able to do the controls at that namespace level, it allows you to roll out more aggressively a move towards a default deny by targeting your most important components, most important teams, and you're not waiting for the whole cluster to catch up before you can implement a default deny strategy. So there's two real things that we were trying to achieve here. One, really a default deny through the namespace network policies, which we do by following governance and chasing up on teams, but then also giving our security team the confidence that they can deny any egress out of the cluster centrally. So that's one use case. Pete's going to walk through the second use case that we have, which is a slight variation on this. But again, it's really a focus on how do we enable the service owner, which in Pete's case is going to be about a database team. How do we give them all the access that they need to administer access control to their resources? So Pete, over to you.
Cool. Cheers, Joe. So if we start with a similar diagram, so we still have the same state of the cluster, where the Kubernetes cluster, the namespace within that cluster, should be owned, maintained, and managed by the tenant. So not by the team that's maintaining or hosting the Kubernetes cluster. We want that control to live with users of the platform, to give them direct access to the underlying Kubernetes resources, rather than having any sort of interfaces that would abstract them from that layer. And as Joe said, we would still be including that admission controller to do sort of standard sanity checks and sort of governance, but from then onwards, we would want the access to be as vanilla as possible. So the second use case is around securing access to external resources. So as Joe talked about, a really good example for us, and this has come up already in production, and we're following this exact model in production, is we need to allow only a subset of namespaces to be able to access a database that lives outside of the Kubernetes cluster. So the core platform that Joe was describing primarily hosts stateless apps. All of the persistence will live somewhere else, owned by a separate team, still living on a private network. So in this example, we've got a Class A range that hosts our Kubernetes cluster, and then a Class B range or a different CIDR range, which is where the database lives. So effectively, the requirement comes in from the DBA to say, we only want to allow 1 or 2 namespaces or teams access to our database because it's a very secure database. And in a standard sort of firewall model, we would probably have firewalls in between the 2 services, and it would be very easy to restrict that. But with our model, because it's multi-tenanted and we don't have dedicated hosts, and we wanted to try and keep it as homogeneous as possible, the actual source IP addresses when the applications try to contact the databases will come from a very large range, and it will not be application or Kubernetes aware. So this is where cluster-wide network policies came in for us. So what we have done is we've effectively applied a global cluster-wide network policy that restricts access to that 172 address range in this example, and it effectively moves that perimeter that Joe was talking about for the egress access over to the actual database from within that cluster. So obviously outside of the cluster it's completely separate, but from within that cluster, the access is restricted to needing to abide by that cluster-wide network policy. And we've also used new features within that cluster-wide network policy around tagging. And this effectively allows us to state that only given namespaces that fit certain tags are actually able to egress and talk to that database, which effectively allows us to still grant application teams access to their namespaces, but also allows those DBAs to be able to create these network policies. And the last little section, I think, if you go next again, Joe. So this is where the actual creation of the resources come in. So it's kind of V1 of this design is we have a core team repo, which is where all of the resources live, which is where this cluster-wide network policy would reside. The database team would then request to own that range and create the cluster-wide network policy and only allow access via a certain subset of teams. That would then be put in to the cluster via a PR process currently, and that would then be applied. The next kind of iteration for this for us, because we effectively want to move ownership of resources, and in this case, it would be that cluster-wide network policy to the owner, which in this case would be the DBA team. So we're currently looking into ways in which we could actually allow teams to have some sort of CRD that they create that they would then own a given CIDR range. And then based on that, we would be able to create various gatekeeper constraints or potentially some cluster-wide policies that would then allow them to actually create cluster-wide network policies and allow teams that they would have awareness for access to their database layer. But that's more sort of V2. But that's kind of the design at the moment. I don't know, Joe, whether you want to add anything extra to that.
No, I think that's right. I would say that we definitely would never really want to leave it in this state, because our priority is always to minimize the interactions any of our tenants, including the DBAs, have with us as a platforming team to do their job on a daily basis. So very much the goal is to replace this PR mechanism with, like Pete said, a CRD mechanism that would allow the DBAs to control access to their secured resource from our cluster once we've given them ownership over a CIDR range, which would be a far less frequent event.